Assalamualaikum everyone, this is Juwairi Ahmad, roll number 2022, CE10. I'm currently studying computer engineering at UT Lahore and in 5th semester. So today we will see the CS5150 lecture number 10, which is all about architecture. We'll focus about architecture, UX and program design. Then we'll see infrastructure, interfaces, services and operations. Then we'll see aim for high cohesion and low coupling in groupings. And after that, we'll see client server, layered, and pipe and filter. These are architecture types. So let's have a look at the lecture in detail. System designs. Design steps. Given requirements, must design a system to meet them. System architecture, user experience, program design. So these are basically the three different types of things that we have to see during designing. Design principles. Wait, let me see if I have the handouts as well. Okay, I don't have the handouts, so I will go with these slides. The design, especially creative part of the software, strive for simplicity. We actually see that less is more. So yes, we have to design strive for simplicity. It helps both client and the developers and designers. Then easy to use correctly, hard to use incorrectly. We also have to see this. We see these all things in details in the 16th lecture as well, where we see program design in details. But here, yes, it must be a property of the design. It must be easy to use correctly and hard to use incorrectly, and there must be low coupling and high cohesion. So what high cohesion means? It means that the design must be dependent on itself rather than low coupling means coupling means k depending on others' design. So it must be low coupling and there must be high cohesion. What is architecture? Conceptual integrity is key to usability and maintainability. Architecture maintains conceptual integrity. So what is conceptual integrity? Which it is basically key to usability. What is usability? Usability means that how much the system is better to use, and maintainability means how can we maintain it in more easy way. Then we have dominant influence on non-functional system characteristics. Level of abstractions, here we have requirements. In start we actually see the requirements, which is basically the what part of the project or problem, which is high level part. In architecture we actually see both how part and high level part and mid level part. High level part is basically the design, which is about how, and mid level part is basically the requirements. Then we have program design, which is how and what part both as well, where we design that what are basically the requirements and how we will implement them. Then we have code part, which is basically the low level part. Here the developers are included, and we see how can we implement it. And then documentation is basically for each step. Then examples, requirements, drone can hover. Okay, so this is basically a requirement. Okay, and this is basically given by the client. Then architecture, uh, for hovering, we actually firstly sense, then we navigate, control, execution. Okay, these are basically the designing, and this is basically the radio input. Then program design, PID controller, low pass filter. We actually see all the things that we have to include in the drone. Then this is the code part. Architectural considerations, we have infrastructure we have hardware, operating system, virtualization, which we see in detail in other lectures. Interfaces, networks and buses, which actually buses include three types of buses, like data bus, control bus, system bus. Then we have protocols, etc. Sorry, Services include databases, authentication, then we have operations, which include testing, logging, monitoring, etc. Then we have architectural models, program and supporting specification, diagram and supporting specification without with notation. Sorry. Yes. So multiple perspectives, conceptual, static, dynamic, physical. We actually see all of them in the future lectures as well. Then we have distinct from program models. Inheritance diagrams don't show interactions. We have examples, packing to board control system. You can actually explore these slides as well. Subsystems improve comprehensibility of subsystem by decomposing into subsystems. Uh, we actually see here the work breakdown structure. So yes, what we saw in the start, coupling, dependencies between two systems. If coupling is high, cannot change with one without affecting the other. While on the other hand, which it is cohesion is basically dependencies within a system. High cohesion implies closely related functionality. And this is basically the UML package, which is general grouping of system elements. Please let me see if I'm recording or not. Yes, it is recording. Conceptual diagram, lexical analysis, parser, and then we have code generation. Like firstly we analyze, then we design, generate its design, and then we code generate its code. UML component, what is basically a component? Okay, basically these are basically used in the UML diagrams, where we actually see component diagrams as well, which I guess we will see in the 16th lecture. Replaceable part of a system confirms to and releases a set of interfaces, etc. Distinct from classes, classes may have fields or are assembled into programs, but components uh, realize interfaces are assembled into systems. So they are basically assembled into systems and they are basically assembled into programs. Interface diagram. I have also discussed this in, I guess, in the 11th lecture. So, in simple, web browser is basically here we have web browser which is on the client side. Then we have HTTP. This is basically an interface. This is basically the dependency which is showing that we actually use this symbol to show the dependency and this for realization. And this is the interface. Web server is on the server side. Now we have node. Physical element that exists at runtime provide a computational resource. Okay, so what it is, anything that is forming the network is basically a node. So computer, smartphone, network router, these all things that are included in the network are actually the nodes. Components live on nodes. Deployment diagram. Here we have web browser on the personal computer. Yes, I told you that we have on the client side, and this is basically on the server side. Here it has web server, and we also have database, which we have actually in the three-tier architecture. These are basically the components. These three are components. This is basically the dependency, and this has dependency on the database as it is taking data for the code. Deployment environments, development, production, staging, acceptance testing. Simulator is basically used to see without actually running in the real world. Architecture styles, we have client server, as I told you earlier, we have web browser on the client side, and we have um, the 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 server on the server side. And this is basically showing the dependency, and this is basically the interface, and this is basically the realization. Control flow in client and server are independent. So these are basically independent. If protocol is fixed, either side can be replaceable independently. Like if the protocol is fixed, then you can replace either of these sides. Then peer-to-peer, same component and act as both client and server. So this can can act as server as well and as client as well. Then this is basically diagram layered. We have partitioned subsystems into stack of layers. Layer provides services to layer directly above, and layer relies on services to layer directly below. These are basically the dependencies. It is showing constraints coupling. Constraints are constraints coupling, so it has more coupling. Leaky abstractions. Okay, so we actually don't know how it is done, but it is done actually. So you can also see the slides as well. These are examples: pipe and filter. Here we have transformation components, process inputs, and produce outputs. This is basically one thing, and then we have filter as well with all of them. So actually, transformation components process inputs into produce outputs. So we have input and then we have output. Example, repository. We all know repository, how we use it. We actually also create repositories on GitHub, which help multiple of the programmers or developers to work concurrently on the with each other, and also we can use other CI tools as well. Input components, then transactions, and basically the commits that we do are basically the transactions. Flexibility, throw in direction. These are examples, compilers, examples, and they are basically credits. Architecture diagrams adapted from work by William Arms. So this is all for this lecture. If you have any questions, you can ask in the comment section. Um, Thank you so much.